Welcome to our MathLinks webinar, Dig into Proportional Representations Floor Plans. I'm Shelley Kriegler, one of the authors of MathLinks. Our presenter is Mark Goldstein, another MathLinks author. Take it away, Mark.
Thanks, Shelley. Let's get started. In this session, we're going to start by using a ratio strip to explore measurements on a floor plan and connect the ratio strip to a double number line and equations. Then we'll solve some problems using these different representations. First, let's make a distinction between proportional reasoning and proportions. Proportional reasoning involves comparing quantities multiplicatively. For example, if you can buy 2 oranges for $1, then at that price you could buy 4 oranges for $2. A proportion is a special kind of equation. It states that the values of 2 ratios are equal. Incidentally, the writers of Common Core chose not to use this word in the content standards. They consider it an unnecessary extra layer of vocabulary because it's just an equation. Here are some common tools or representations we use in middle school to explore proportional reasoning. Our ratio strips are going to connect directly to these two, and then later you'll see how the double number line connects to the proportion equation. This is what we call a ratio strip. You can see the centimeter measurements by increments of 2 and feet measurements by increments of 9. This defines a ratio of 2 centimeters for every 9 feet. Let's try using the ratio strip to measure the dimensions of this drawing of a garden. The length of the picture is 2 centimeters, so the actual length of the garden is 9 feet. The width of the picture is 6 centimeters, so the actual width of the garden is 27 feet. Notice also that we can multiply both length measures by 3 to arrive at the width measures. Or we can multiply both drawing dimensions by 4.5 to arrive at the garden dimensions. So we can conclude that these are equivalent ratios. The value of the ratio 2 to 9 is the fraction 2/9. And the value of the ratio 6 to 27 is also the fraction 2/9. This confirms that we're working with equivalent ratios. We leave it to you and your students to explore further. For example, what's the relationship between these areas? I'll give you a hint. It has something to do with the multiplier 4.5 mentioned before. You can find this handout posted on our website, which is listed at the beginning and the end of this session. Now, here's a floor plan to explore. What might we wonder? Is the scale we used before reasonable for this floor plan? What are the lengths and areas of the drawing in the house? What's the square footage of the house? Square footage is a very common consideration when selling or buying homes. This handout is posted in the same place as the other one. As an extension, give students some choice about what they might want to draw to scale and create a ratio strip for measuring it. Let's switch gears. A ratio strip is really a different version of a double number line. We start at 0, and here's the ratio that represents our scale, and here are some equivalent ratios. Sally is going to make a drawing of a floor plan using this same scale. On Sally's scale drawing, a room is 5 centimeters long. How could she use a double number line to find the actual length of the room? Here's the double number line from before. This tick mark represents the halfway points between these two ratios. We can calculate these values and conclude that 5 centimeters represents 22.5 feet. On Sally's scale drawing, a fence is 20 centimeters long. But notice that 20 centimeters is beyond the centimeter values we created on the double number line we've been using. We can choose to extend the double number line pretty far, and we can cleverly choose a friendly number and figure out a simple multiplier, and conclude that 20 centimeters represents 90 feet. Here's another way to figure out the same problem. This represents the unit rate, and then we can simply use 20 as the multiplier to arrive at the same result. Here we turn it around and are given an actual length and are asked to find the length on the drawing. Again, the same double number line. We know roughly where 33.75 feet is. You should know that this is an estimated placement, and we're using the variable x to represent the unknown number of centimeters for 33.75 feet. Let's focus on these two ratios. First, the given scale, and also this ratio that includes our unknown. This visual really helps in setting up the familiar proportion that we as adults are so used to seeing. Once students have some experience solving this type of equation, they can go through the steps to arrive at the result. Now, let's turn to another problem. Here are the details of Freddie's floor plans. Freddie's problem involves finding 60% of the length of the house, and a double number line can help with that too. We were given that the length of the house on the drawing is 30 centimeters, so that represents the whole length, or 100%. The number lines are in 10 equally spaced parts, and the halfway point represents a ratio of 15 centimeters to 50%, or each tick mark represents a ratio of 3 centimeters for every 10%. And counting ahead to the 60% tick mark, we see that matches up with 18 centimeters. So we know that the drawing of the living room should be 18 centimeters long. We can do the same problem using a proportion equation. This bare bones double number line helps to illustrate the relationship between some knowns and the unknown. And this helps students see how to set up the proportion appropriately. And then we solve the equation to arrive at the same result. The previous problem addresses a 6th grade standard in Common Core, namely finding the percent of a number. This next problem addresses a 7th grade standard, increasing a number by a percent. Our double number line can be effective for this type of problem as well, and we can show two related ways to think about solving this problem. We can number up to 20% and realize that we'll have to increase the 30 centimeters by 6 centimeters. Or we can number 20% past the 100%, and we end up at 36 centimeters. And we'll follow up with the same problem, again using a proportion. We use our bare bones double number line and highlight the relationship between some knowns and the unknown, which leads to this equation and the solution. In this session, we started with what we call a ratio strip and used it to work with scale drawings. The ratio strip translated nicely to a double number line, which in turn helped us set up proportions. We hope you enjoyed it.
Thanks, Mark. That was really great. I loved all those connections. The Center for Mathematics and Teaching is the home for all MathLinks programs. These include Common Core programs for grades 6 through 8, intervention programs, and professional development. You can learn more about our programs by visiting our website at www.mathandteaching.org or by contacting us directly. Thanks for joining us. See you next time.